Today is all about flashing programs to AVR microcontrollers. Hey everyone, Chris here. Today is a bit of a bonus video. This is really just for reference. Recently, I've been working on the 3D Chameleon project. And to get the firmware on the 3D Chameleon board, to upgrade it, you have to flash the AVR microcontroller that exists on that board. And to do that, it takes some specific steps. You have to know a little bit about what you're doing to get it to work successfully. And I found there's a few hoops you have to jump through and a few gotchas in getting something like this done. And there are multiple ways of achieving this, flashing some software or a program over to an AVR chip. Now, you might remember back in the day we had to flash bootloaders to boards and things like that to get them to work or to put different types of firmware on them. It's a lot the same thing. I'm just making this video to show you what I've learned about this whole process, and it might help somebody in the future. You never know. So we're going to jump into it. There's lots of acronyms and different things here surrounding all of this that don't make a lot of sense, and I'm hoping to smooth all that out for you and to give you all the tips that I've learned to make this happen. So let's get into it. So let's start here with the problem that we're trying to solve. Now, this is the controller board for the 3D Chameleon. The Chameleon is a multi-material module you can get from 3D Chameleon. It'll do 4 colors, 2 colors. We're going to see all about that in later videos, but they have these controller boards with 2 drivers on them. And it has an Atmel Mega 328P chip on it. But notice there's no USB interface. You can see their cool logo there on the back. Now, my board was pretty old. It was a Mark II style. They have newer versions of firmware that you can flash to enable the new features. And that's what we're trying to do. We're trying to go from the Mark II firmware to the Mark III firmware. But you have to have some type of programmer to be able to program this chip. This is an AVR chip made by Atmel. So AVR is the type, Atmel is the brand. And that 328P is the model. The interesting thing about AVR chips, they were some of the first microcontrollers like this to have onboard memory. And that's where we want to put the firmware. That's why we need to flash them. With this, you want to flash it with a programmer, but you're going to use these ICSP pins. ICSP, that stands for In-Circuit Serial Programming. It's an SPI interface. SPI stands for Serial Peripheral Interface. So there's a whole bunch of acronyms you didn't know the meaning of before. So the root of this problem, we have our Chameleon board that has some firmware on it. We would like to update to the newest version so we can take advantage of the new features for a multi-material unit. And the easiest way to do that by far is to use another device that already has an AVR chip on it that might already have a USB interface as well. The most common being an Arduino of some type. So this is an Arduino Uno clone board, probably the most common one that you're going to see. They're very affordable. This is the easiest one to use to flash a different kind of AVR chip. And it just so happens the Uno uses the same chip as the Chameleon. It's that Atmel Mega 328P chip. Now you'll notice we have the same programmer pins over here, ISCP. So you could talk to that chip with those pins. But what we're interested in doing is using the USB interface to load a program that acts as a programmer for other chips like this. And that allows you to use the inputs and output pins on the headers of the Uno. I'll show you more of that here in a moment. But you also have other options rather than an Uno board. These are ISP programmers, in-serial programmers. This is what they call the USB ISP, and this is the tiny USB ISP. The only real difference you need to know is the chips are a little bit different and you have to use a different driver, but they're going to achieve the same thing. Basically, they give us a USB interface to be able to use this to go through to another Atmel AVR style chip. These can be a lot handier because you don't have to use the jumper wires like we would on an Uno board. They'll come with something like this, a ribbon cable. You can cable directly up to those ISCP pins on the device that we're trying to flash. So whether you're trying to use the Arduino Uno board to flash your AVR chip or a programmer, I'll walk you through the steps on how to get all that done. Let's start by cabling up the Uno board so I can show you how. Also note, the 3D Chameleon folks have a lot of this information in some docs. The same stuff that I'm going to tell you. I'm just going to show you all the little things that I ran into when I was trying to do this same thing. But this will show you how to cable up to an Uno and get the same thing done. They even have a setup here that you can use LEDs to get the status of the board as you're trying to do these types of things. The main thing that we're interested in here is the pinout of our Chameleon board. You have this serial interface, SPI interface. We need to know which jumpers to plug in to our Uno board to make it communicate. And these are the pinouts that we're going to go after. Let's set that up now, and then we can continue with the rest of the stuff here in a moment. Let's just work on the Uno side for a minute, and then we'll plug it into the Chameleon board. But basically, we're after these pins 10, 11, 12, and 13. And then we need 5 volt and ground from over on this rail. And I'm just going to use some of these jumpers to get this done today. I have my own cable that I use for things like this. I like to make a permanent cable. They're a little bit more consistent. But you can get it done with these jumpers. Just make sure absolutely, positively, that these have good continuity. Or that's the first thing that you're going to run into. You won't be able to flash because you have a bad one of these jumpers. So double, triple check all of the connections. But for starters, over here, we're just going to grab 5 volt right there. And then next to it is ground. And then we'll use a yellow for pin 13. Our 12 will be our blue wire. Green will be 11. And I don't have another color of these jumpers, so we're going to have to use another yellow one, and just be careful. But we'll use another yellow one here for 10. Now on the Chameleon side, you want to have the board facing this way, the way I do the camera here, because it's easier to understand the pins. This is pin 1 over here, so 1, 2, 3, 4, 5, 6. So pin 1 will go to D12. That's our blue wire. Pin 2 will go to 5 volt. So that was our red wire over here. Pin 3 will go to D13. So that's our first yellow wire. Pin 4 will go to D11. So that's our green wire. Pin 5 is reset. That goes to D10. That's our second yellow wire. And then pin 6 is ground. So there's a look at everything all wired up. Again, there's a lot better pictures in the documentation. All of that will be in the description. But here's a look at the Chameleon side and another look at the Uno side. Now, we're going to use the Arduino IDE to create the ISP programmer on the Uno, the software we need to make it a programmer. And then we're going to use AVR do to command line flash the Chameleon board. I'll show you how to do all this, but I highly recommend you uninstall Arduino and clean up and start from scratch before you attempt it. So just so I can show you the steps, we're going to do that now. I'm going to go to Windows key, and I'm just going to start typing Control Panel. So I want to go to the Control Panel app. I'm going to uninstall a program. Arduino, uninstall. So that will uninstall the actual Arduino program, not the Microsoft app. But you don't want either installed. So we've got one taken care of. We need to check for the app. So let's go back to the Windows key. And we'll go to Settings, this cog right here. And we'll just go to Apps. These should all be in alphabetical order, but you want to make sure there's nothing in here that says Arduino. If there is, click on it and then hit the uninstall button. We should be good here, but having both of those installed can cause problems. And the one that's from the Microsoft Store, the app, doesn't work all that well. I'm going to show you how to install it from the install package from the site. So I'm cleaned up here. This should be good. But we also want to delete any files that we might have locally. So we're going to open up File Explorer. We're going to go to our C drive, Users, and then pick your username. And then we need to head into App Data. But you might not see App Data because it is a hidden folder. If you can't, go to View and tick this box that says hidden items. We want to make sure that we can see everything. Also, if there are any files up here that say Arduino or Arduino IDE, go ahead and delete those as well. Those could be saved parameters that we don't want to save. We want to start from scratch. But now that we can see app data, we'll go in there, we'll go to local, and this Arduino 15 folder, we're just going to highlight it and delete the whole thing. That will get rid of any existing projects that we might have had that might confuse things. So now that we're cleaned up, we can go get a new version of the IDE, the Arduino IDE, and start installing. So we're going to head to the web, and we're just going to search for Arduino IDE download. And we'll go to the Arduino site. There is a new 2. Version out. I like to stick with the 1. Version. The newest one as of today is 1.8.19. This is the one we're going to go with. And we're going to get the Windows installer version, so this top one right here. So we'll click it to download. Once the download's complete, we'll head to the download folder, we'll double click on it, and get the install started. We want everything that it has installed, including the drivers, and we want it to be in the default location, and that should be Program Files x86 Arduino. This is important because we're going to enter some path variables here in a minute, and they'll be in this location, so it has to be in the stock location. You could move it, but it won't follow along with this video. Anyway, default location, install. Once the install is complete, we can close this. We don't need to open it quite yet. We want to talk about USB devices, COM devices on your Windows PC so you know which device we're talking about. So let's head to the Windows key again. You can actually right-click on the Windows key and go to Device Manager. Now, you'll notice on my list, I don't have anything listed as a COM or LPT port because I don't have anything plugged in that is one of those devices on my PC right at the moment. But before you plug your Arduino board in USB, bring this up and then notice what different devices show up after you plug it in. So we'll take our USB cable, we'll plug it into our Uno. We're already cabled up to our Chameleon board, and then I'm just going to plug in the USB cable to my PC. Both the boards should have lights to show power. And now in Device Manager, you can see we have ports, COM, and LPT listed. If you expand that, here's our Uno board. It's on COM 9, and you're going to want to remember that. Now, you can see that this board is listed as a USB serial CH340. That's because it's an Arduino clone board. If it was a genuine board, it would actually say Arduino Uno. Not all CH340 boards are going to come up like this, and you might need a driver for it. So now that it's plugged in, even if you don't see it here, if it's in an unknown device, you have to install that driver, and then it should be listed just like this. But you might need that CH340 driver. So let's head to the browser. This Sparks of Fun article shows you about CH340 drivers, and it gives you a downloadable link. This is the best place I've found to get that link, but we'll scroll down and we'll just grab the executable of that driver. Download's complete, we'll open it up. I'll show the Device Manager at the same time, but if you have a CH340 device plugged in USB like we do right now, and you hit install, you can see the device is going to go away for a second while it's installing it, and then it will go as success. That's how you know you've got the CH340 installed, and now your clone device should work correctly with Windows. That's just a side tip. If you do have a clone device, you're probably going to need that CH340 driver. But now we know it's going to work. It's on COM 9. Now we can proceed to the Arduino IDE. So we'll just open up our IDE. And the first thing I recommend you do, since the Arduino IDE opens up a blank sketch, we can just upload that blank sketch to our Uno to make sure it's cleared out, it's back to 0, and then we can proceed from there. So just with this open, go to Tools, make sure your board says Uno. This one does, it should by default, and then pick your port. We saw that it was on COM 9. And then you can just hit the upload button. It will compile the sketch and then send it to your Uno. You can verify that the Uno is talking. It will flash a few times while it's sending that sketch over. And then down here you can see it's done uploading, and it uploaded successfully. So now our Uno board has nothing on it, just a blank sketch. Now we need to turn our Uno into an ISP programmer. So something that's going to talk over these pins to the ISC pins on the Chameleon board. And there's example sketches for that. So we'll go to File, Examples, Arduino ISP, Arduino ISP. And you don't need to know much about this. Just know that it's calling out the pins that we cabled up that you saw earlier. 10, 11, 12, those are the pins we need to talk to our Chameleon board. So everything is set up here to turn that Uno into this programmer. So you can just go ahead and upload it because we know you've already got your COM port and your board selected correctly. So we'll hit upload. Again, you'll see the board lights communicate there. And when it's done uploading, like it shows here at the bottom, we now have our Uno as a programmer. So we're ready to use it to get our firmware over to our Chameleon board. Now for this project, we don't actually need the IDE any longer, so you can go ahead and close it. But when we installed the Arduino IDE, it gave us a program called AVR do. And we're going to access it via command line. The biggest challenge is that program is buried. It's way deep in the file system, and if you were to try to run it right now, your computer wouldn't know what it is. So let's go to the Windows key and type in CMD to pull up the command prompt. If we type in AVR DUDE, it has no idea what that program is. So let's jump back to the File Explorer. We'll go into C drive, Program Files x86. Remember, this is the default location where it installed the Arduino IDE, Arduino. And then if you go into Hardware, Tools, AVR, Bin. There's the program that we're looking for right here. Now, because it's buried in this file system, the command line can't find it. So what we can do is update the Windows variables, environment variables, so that we can get to that file at any time. So if you click up here, that's going to give you the location of the program we need to run. So we're just going to Control-C to copy that location, or you can right-click copy. And then we're going to go Windows key again. We'll do Control Panel, open that back up. We'll go to System, and then System again. And then over here on the right, we're going to do Advanced System Settings. And in this box, you'll have Environment Variables. Now, in environment variables, this is just different things that you can set to be permanent in your Windows system, so you don't have to do things like we're getting ready to do. You don't have to go to an absolute path, shortcuts, different things that you can set up in here. The top one is for users. So what user I'm using will be able to use this path or shortcut or whatever might be in here. Down here on the bottom, if you change these, that will impact every user on the system. I like to just go ahead and update the system part because I know it's going to work for every user if I happen to use a different user for a different project or something like that. So we're going to update the system variable. So scroll down a bit until you find path. And we're going to add a path to that AVR do program. So we'll hit Edit. You can see a list of the different shortcuts, the direct paths to different programs. We're just going to hit New. And we'll paste in that path that we found in Windows Explorer where that program is and hit Enter. Now we need to add one more path, and that's the path for the AVR do configuration file. It has to know where it is as well. So back to Windows Explorer. We're already in this big long path up here, Tools AVR Bin. We're going to go up a layer and we'll go into ETC. That's where the configuration file is. So again, we're in the ETC. We've got this big long path. We'll click on it, right-click Copy, and we'll go back to System Environment Variables here, where we're updating the path. We'll hit New again, and we'll paste it here. Now we're good. We have an absolute path in our environment variables, so we don't have to go there to that exact directory to be able to use our program successfully. So hit OK, and hit OK, and then OK again. And now you can close this stuff out. Now, that's a really long way to get you where you need to go to run this program. But again, I'm trying to give you all the tips that I know to get this done successfully, because it's not always the most straightforward. And this is going to work for anything that you need to program in the future. But now that all that's done, we can go to Windows key and type in CMD again to find the command prompt. And now, no matter what location it opens, if you type in AVR DUDE, you're going to get the help screen on how to use it. That's how you know that path environment variable worked, and you can call this script from anywhere you want. So I know this is a lot. It's a lot of clicking around and things you have to configure to get this to work. And you might be able to do this a lot faster, but again, I'm trying to give you all the information that I know about this because I did have a lot of issues with it, and I have different issues with it depending on the board. This should be the best way to get any of it done, no matter what board you need to flash or what programmer you're using. So hang in there with me, we're almost there. So now everything's installed. We've verified that AVR do is working. We've got our cables from our Chameleon board over to our Uno successfully, and our Uno is plugged in USB. We're ready to start talking to it and then flash our Chameleon firmware to our board. The first thing you want to do is verify that everything is working with AVR do and your Uno board. So we're going to do AVR DUDE space dash capital P, and then the COM port that we saw in the Arduino IDE or in Device Manager. Ours was COM 9. Next, we want to set a baud rate. So do -B, and you can put a space or not if you want. Both will work, it doesn't matter. No space for me, but -B. The baud rate for this, 19200. Next, we're going to specify the programmer type. So do -C, and we're using AVR ISP. And then we need to know what type of chip we're talking about here. So -P, and remember we saw it was a Mega 328P. That's the type that's on the Uno, as well as the type that's on the Chameleon board. They don't have to be the same. We're interested in the one that's on the Chameleon board because that's the one we're talking to. At this point, our Uno is just a pass-through. And then if you do a -V, you're going to have verbose output so you can see what's going on. Again, this command isn't going to flash anything. It's just going to test it, make sure everything's correct. So we'll go ahead and hit enter. You'll see some lights flash on the Uno, probably the Chameleon board as well, but you want to make sure it read it and you have the correct information here. Now, I don't know exactly all the stats, but just the fact that it said it was done and thank you, you should be in good shape. You should see all the safe mode fuses, all this stuff. It should look exactly like this output. I have this output in a dock. If it doesn't look like this, there's probably something wrong. It's going to tell you if you have a bad connection or whatever it might be, but this is what it should look like if it's set up successfully. Now you're ready to flash your 3D Chameleon file or any hex file over to your new board. Over on the 3D Chameleon forum, they have the firmware for all the different versions. Again, we're trying to get to the Mark III firmware, so it's this guy right here, and we'll download it. We'll head to Downloads. Again, this is our firmware. I'm going to right-click on the zip file and extract all. This is the .hex file that we need to upload, and it does have to be a .hex file. You can compile .hex files in the Arduino IDE, just for your information. That's probably where this one came from, but this is the compiled version of the firmware that's ready to go on that Atmel AVR chip. I'm going to put it in a location that I know where it is, so I don't have to navigate deep down into these folders. So I'm just going to right-click and copy this, and I'm going to put it on my desktop. So I'll just paste it right here. Now that we've got our firmware in a familiar location, we can flash it. So we have our AVR do program set up so that we can run it from anywhere. You saw that with the environment variables. Now we just need to navigate to the location of our new hex file. So I'm in my username right now. Your username is going to be different. I use OneDrive, so my desktop folder is actually in the OneDrive folder. So I'm going to do CD to change directory, and then OneDrive. In OneDrive will be desktop, where I copied and pasted that file just now. So CD, desktop. You can do a dir to list all the files in there. Mine's a rec. But you can see that .hex file right here. This is the one that we need to flash to our board. So now we have to punch in kind of a lengthy AVR command to get it to flash. So it's pretty much the same type of command, only we have to add that file name in there and a few other parameters. So AVR DUDE, again -P and tell it your COM port. Ours was COM9. Space -B and then your baud rate, 19200. Space -C, what type of programmer? AVR ISP if you're using the Uno. Then -p, what type of chip are we flashing? We have that Mega 328P. Space, do -V so you can see all the output. Then we want to do a -E, space, -U. Then we want to do space, flash, colon, lowercase w, colon, and then the firmware file, the .hex file name that we want to flash. And this is it right here. You can just highlight it, right click to paste. So there's our .hex file name. And then after that, you want to do :I, lowercase I. That's kind of a long command. Again, these commands are in the documents. You can just copy and paste. But this is what it's going to do. This is what it's going to take to flash it. So we'll hit enter. It's going to give you a status. It's going to show it reading, then writing. It's actually writing to the Chameleon board. It reads it back. And now your board is flashed. So now your new firmware is on your Chameleon board. And remember, this is going to work for any board that has an AVR style chip. And it might seem like a lot of work to get this set up, but if you're going to do this type of thing or you need to upgrade something, you're probably going to have to do it again in the future. And now your PC will be ready to go to start running those commands. You can just get the new file, run the command, you're updated, ready to run. Now, we don't want to stop there. What about if you have a programmer? If you're going to do this a lot, you're probably going to want to get one rather than an Uno board. So let's jump through that real quick. So we're going to take our Uno out of the picture. Our Chameleon board already has the firmware on it, but we can use it as a test case. We're just going to unplug it and we'll take our Uno and set it aside. Let's start with our USB ISP here. This just plugs into a USB slot, but again, they come with ribbon cables to make it easier to cable up to your ISCP pins. So one side will just go into the USB ISP. The other side will go into your pins onto whatever board you're trying to communicate with. Our Chameleon board, if you remember, our 5-volt pin is up here. Just line that up with the pins on your programmer. Mine has VCC right here, so it's going to line up just like this. And you can verify that that's going to work because the Chameleon board will light up successfully when you plug this in USB to get the power. So we can just go ahead and plug this into our USB port, and then we'll go back to the computer. Hopefully your programmer has some sort of light to tell you that it's communicating, but you do see the light on the Chameleon, so we at least know that it's plugged in correctly. So we're going to interact with the program in the same way we did the Uno command line, but you have a different device, so you're going to have a different type driver. And it can be a little tricky on some of these programmers finding the correct one. But there's a tool that makes it easier. Back to good old Spark Fun, they have a lot of great documentation and some downloads to help support things like this. But what we're looking for is this Zadig program. It's going to let you install these different types of programmers. So we'll download it. We'll right-click, extract all, and then you can just go into the folder and run this in place. So this one is the USB ISP. So you have to know which device we're talking about, so which driver to use. If you go to Options, you can list all devices. It's going to give you everything USB on your machine at this time. But we'll scroll down, and you can see we have this USB ASP. That's the programmer we're talking about. And it's showing you already driver information, but we can replace that driver, and I want to do it just to show you how this is going to work. I've installed this in the past. But for this, you want live USB Win32. And again, I've already got a driver for it, but I'm just going to downgrade the driver for this video. Once the driver has been installed successfully, we can close this out. We'll use this again here in a moment, but go back to Device Manager, right-click the Windows key, Device Manager. You'll see this live USB device, and there's our USB ASP programmer. Now you can use this as a device instead of that other ISP that we used during the Uno board. Just remember, USB ASP. You don't necessarily have a COM port for it. So just like before, we will CD into OneDrive, and then CD into desktop, because that's where our hex file is located. We'll do a dir. There it is. You can go ahead and copy that if you want to. And then we're going to do the same type of AVR do command. So AVR, DUDE, and you can tell it where the port is, just like we did before. You probably don't have to, but if you want to, -P, and it's USB this time. We don't need a baud rate because it's on USB. We do need the programmer, so -C. This time it's going to be USB ASP. And then the type of chip we're flashing, so -p, and that's not going to change, M328P. And then we need the other options to tell it about the hex file. -V to get the extra logging, -E, then -U, space flash, :w, then your hex file name. If you selected it, you can just right click and paste, :I. Hit enter. You should see it read, then write, then read again. There might be a few errors depending on the programmer you're using, but as long as you see this information down here, you should be good to go. So that's one type of programmer. And this is a tiny USB programmer. It does the same thing, you just might need a little bit different driver. This one has both the 10-pin and the 6-pin cable. We're using that ISCP interface, so we're just going to plug in our 6. And then over here, that red wire should go to your 5-volt side, which is up here on the Chameleon board. So just like that. Again, to test it, we'll plug it in USB. This one just has an AB cable, so we'll plug this in. Should get a power light on both. That's how you know you have it set up correctly. We're going to go through the same process that we did for the other programmer. It might be a little different driver, but we'll open up Device Manager one more time. We don't currently have that device listed. We do have one here, but it's for the keyboard. So we'll do our tool here and go list all devices. And you can see we have USB Tiny ISP. For this one, you're going to want the live USB Win32. It should be the same. You might try some of the other ones if you have issues, but this one should work for this style as well. So we'll replace the driver. Driver's been installed. We can close this out. You can see over here it's now listed as the Tiny ISP. And then we can open up the command line again and repeat the same commands, just changing these up a bit. Again, make sure you're in the same directory as your hex file. We're on desktop. And we'll punch in our AVR do command one more time. AVR DUDE. Again, you can do port if you want, -P, USB, space the type of chip we want to flash, -p, M328P, and then our type of programmer, -C. This time it will be USB Tiny. And then the other commands to pull in the file, -V, extra output, -E. We should have this memorized by now. -U, space flash, :w, the hex file name, :I, and hit enter. Again, as long as it reads, writes the chip, reads it again, you should be in good shape, and you see all the information for the fuses. So we should be good. 3 different ways to flash an AVR chip, and we did all of this just so we could update our Chameleon board. So there you go, everything you never wanted to know about flashing firmware over to AVR chips. And honestly, I had a lot of trouble doing this type of thing with different programmers, Uno boards, wires that didn't work, different setups in Windows that would truncate some of the things that I was doing. It was just kind of a mess. So I decided to make this video as well as a document to keep for my notes if I ever have to do this again, and hopefully a lot of this will help you out as well. So hopefully you found this helpful. That is it for today, and I'll see you really soon on the next one.